experiment using minow software. So now let's open minow software on our computer. And in this first stage, what we're going to do is we're going to log in. And we're going to log in with our Nanopore community credentials. Make sure that you have an internet connection at this stage. So once we log in, we're in the connection manager and we can see we have our minow already plugged in. This should take you to the sequencing overview, and you can see we've already checked our flow cell. We have our flow cell ID here and a green tick that says it passed the flow cell check. So what we're going to do now is we've primed our flow cell and we've loaded our library, and we're going to go onto the Start tab. So now we're going to go into Start Sequencing. So this brings us to the first tab, which is Positions. In here you must add an experiment name. You can see here you won't be able to move on until you do. So in this case, I'm going to call my experiment a control in lambda, as this was the sample that I've run. You can see our flow cell IDs I already identified. We have the flow cell type, which is correct. And you can also give a sample ID. If you don't give a sample ID, then this will take the experiment name. So in this case, I'm going to call it lambda as well, as this is the sample that I've run. Another thing you can do here is you can load saved settings. And you can see here I already have some saved settings. And what this will do is this will auto-populate all these tabs with the parameters that you've already selected. So this is good if you're running the same experiment multiple times and you don't want to spend time filling out all these parameters already. So we're going to close because I want to go through all of these tabs separately. So we're going to continue now to kit selection. So this is the second tab, and in here you should select the kit that you use to prepare your library. So you can filter these out by the sample type. So DNA will bring only DNA kits, for example, and RNA will only bring up the RNA kits. So this is particularly important at this step because you want minow to know which type of data is going to base call. Specifically for DNA and RNA, you expect different translocation speeds for these two types of molecules. So it's important that minow knows what type of data is base calling, as this can have an effect on your data. You can also select based on whether you've used PCR or not to do your library preparation, and if you've done any multiplexing, or if you're running a control experiment, you can click on Control. And this will actually affect the run options, and it will set your run to 6 hours as default. So I'm going to deselect this now. And in this case, what I've chosen and the kit that I've used was the rapid barcoding kit. So I'm going to select this here. And this is a multiplexing kit. So we don't need to select multiplex expansion pack, but if you had, then you could select this down there. So if you click multiplexing and you select, for example, LSK109, you can see here the compatible barcoding expansion packs that you can select to then barcode. So we're going to go back to our correct kit. So we've used the RBK004, and we're going to continue to run options. So in here, you can adjust your run length. So to default for every flow cell is 72 hours. You can adjust this as you wish. And you can also stop your run at any point during your run. So you don't need to worry about this too much, but you can leave it as default. And this is what we're going to do today. You can also adjust the bias voltage. And this is really only important if you're reusing a flow cell. And for more on that, then please check our relevant video on reusing flow cells. You can hover over these buttons here to understand what these mean as well. So in this page, we have as well advanced user options, and this is on active channel selection and the time between MUX scans. And again, these topics will be debated in a different video, so please refer to that. So in this case, I'm going to leave everything as default, which is what we recommend for most users. So we're going to continue on to our base calling tab, and in here we can select our base calling models. So we have 3 different options for base calling models. We have our fast base calling, our high accuracy, and our modified base calling. So I'm going to go with fast base calling in this case, And again, for more on these base calling models, then please refer to our video on this. So in here, you can select as well barcoding. And this, what minow will do is it will demultiplex your samples automatically during the run. So you can see because we've selected barcoding kit, this was enabled as default. You can deselect to disable this option if you want to do multiplexing post-sequencing run. I want to do multiplex during real time, so I'm going to select this and let it be set up. You can also select the options for barcodes and what you want minow to detect, and as well a minimum barcoding score. Again, if you want to learn more on what these mean, then just hover over this question mark button, which will tell you what these values mean and how you can set them up. What you also can do in minow is you can do an alignment during your run at the same time if you want to align to a reference genome. We're going to leave this as disabled for now, but just bear in mind that you have this option to do this in real time as well. So we're going to continue to output, and in here we can select an output location for our data. I'm just going to leave everything as default, and you can select the output format, and this is the data file types that you can output with minow, which is FAST5 and FASTQ formats. So for more on these file formats as well, then please refer to the relevant video, as I'm not going to go through too much detail in here. You can also filter these based on specific parameters like Q-score and read length. But again, today I'm going to leave everything as default too. So we're going to continue to run setup. And in here you can see we have a summary of all the parameters that we've chosen for our sequencing run today. So at this stage, you can save these settings if you want to run this setup again, and this will pop up in your positions tab the next time you come to set up a new experiment. So now we're going to set up our experiment. We're going to click Start, and minow is going to take you straight away to the sequencing overview page. And the first step is it's going to get to the right sequencing temperature, which in this case is 34 degrees Celsius. So we're going to speed up the video now until our experiment gets to the correct temperature. So our sequencing script has started, so we're going to go into System Messages, and from here you can monitor what's happening. So you can see here that the temperature stabilized to 34 degrees. You can see as well we had a message saying how many space we have on disk. And this is important. You always should have the minimum space requirement for running minow in a sequencing experiment. So minow will warn you if you're running low on your disk storage. So it started a sequencing procedure, and the first bit is it's going to run a muckscan. So for more on muckscan, we have a separate video that explains this, so please refer to that. But basically, minow is going to assess every single pore, and it's going to categorize before it starts sequencing from those nanopores. So this should take a few minutes, and then minow will start the sequencing experiment. So if we go to the Experiments tab now, we can see here that we have our active run. So the sequencing experiment has started. So we can select our active run, and you can see as well different statistics at the top for this active run and from previous runs. And if you scroll to the right, you can see as well some statistics, speeds, and estimated bases that you have produced so far. So what you can do here as well that I've mentioned is you can stop your run at any time. So if you click Stop, you have the option to stop sequencing, and you have the option to stop sequencing and base calling. Stopping sequencing, this will mean that you will just stop your sequencing run, and minow will continue on base calling any data that hasn't been base called yet. If you choose to stop sequencing and base calling, then minow will finish these two processes. So make sure when you do this that you don't close minow before all these processes are finished, and that it says that your run has finished. So that's that for setting up a new experiment using minow. If you want to see how to monitor your sequencing run and assess the performance of your library, then please check out our relevant video on this topic. If you found this video useful, you can browse through more